those of us who have done small data work or they have done some small analysis, we know that Python helps us a lot in the analysis we do. But today we want to take the first step and look at the basics, how we start everything. It starts with your inference. And the inference part is what we will do before we start our machine learning, our models and everything. So they want to go beyond the basis, beyond the starting, beyond the mean and mode. We want to get to understand the next steps and then how these things help us to make decisions or help us conclude on some things when we are doing our analysis. I'm Elvis and I've not graduated yet, so I'll still call myself a final year student at the University of Ghana, and I did computer science and statistics. I combined with your course, which nearly killed me, but yes, I survived. And also, I'm a CB ambassador for Ghana this year, and previously last year, I was the ambassador for Tableau, and it's a data visualization software. Most of the times when I say Tableau, plenty people don't know, but I believe most of us know Tableau, right? Yes, so Tableau is the direct competitor of Power BI, and they do mostly the same thing. That's helping you with your visualization. And to start, I want us to think about this. When you were coming here, how many of you checked which type of cars are available to transport you here and their price options? For example, some of us said, hey, if I go and pick Trotro is this cities, let me use both, let me use this. How many of us made that conscious decision to look at something before they made their decision? How many of us? Or maybe if you are coming for this event, you left it, you were like, should I take the umbrella? No. You let me just go and check the weather. And then you check the weather like, okay, it's not raining today, so I'll not take it. Or you check the weather like, hey, it looks like it will rain, so I'll take my umbrella. Now, the data is what helps you drive your decision. But in analyzing this data, there's a first point, which is inference, which is helping you know where to start from, what your data is looking like, and whether you finally make your decisions or not. This decision you made, or this thing you did, watching your phone, maybe you are going to a restaurant, you want to find out, do they have this food there these days or not? You reflect on something, think through before you analyze, before you make your decision. This is the basics of decision making, statistics. And this is the root of all our disciplines, our decisions we make in data science, analytics. It is this statistical inference. Now, inference is in 3 parts. The first part, I'll mention all of them when we are going through. But somebody will ask, before we even look at inference, why is he talking about inference? Why is he talking about inference here? Now, beyond our models, inference is the root of all analysis. Before you start your data analysis, before you start your analytics, you have to understand that before you even build your model, you have to understand your data. Sometimes, as tech people, we don't understand the domains you are working with. They bring you the data from healthcare. You're like, what does this thing mean? Sometimes there's a story behind the data. It's with these techniques that you get to understand. Okay, so this is what it is, this is what it means. So you cannot get somebody's temperature at this point. Okay, this is it. So you have to understand the domain of the data, and then you can conclude it. Okay, let's take this step, let's use this test, let's use this thing for analysis, and then in the long run, you can conclude on your decision. So it helps us, before we even build our models, to understand and then look at how our data is looking like. Now, behind every data, there's a question. There's a popular saying that the more you ask the data the question, the more you get to discover. And so, before we even start asking the questions, it's these techniques which help us know how our data is looking like, and then what we go about it. And it's used in different disciplines. So I'll take us to an example of how, even in marketing, this type of approaches are being used. And all these have a root in statistical inference. Now, we have 3 types of inference. These types are the basis which we use to conclude on the types of data analytics we have. So the first one is descriptive. Now, descriptive is simple, describing. We want to look at our data, have a brief overview. So in that, you're asking yourself, what happened? And what happened, you want to find the mean. So you want to find the average salary of everybody in this room. Probably $5,000. But you want to describe the data here, you want to describe how the salaries look like. And in these things, The root is descriptive analysis. Descriptive analytics, and that's the first part. And the second part is inferential. Inferential is when you ask yourself why. So why is it that everybody here has a salary of $5,000 and above? And when you ask this question, you have to translate it into statistics. How do you see it in terms of statistics? So is there a significant difference in our salaries here? And then what is causing it? So in Python, the models are there. So scientific Python, the Scipy, and then our Statsmodels, they help us do the statistical test, and they know how to conclude. To tell our stakeholders that, hey, in this conference, most of the tech people have money. So let us come and advertise ourselves here. But it's a fintech people, a payment system. They want to come and tell them that, oh, let's use our platform to tell them that you can receive their salaries through this, so that we get more money or help our campaigns. And this is one thing which inferential statistics looks like. Now, in the analytics side, we call it prescriptive analytics. We'll go to the third one, or the final one, which is predictive. So predictive is like we want to tell the future. Now, in telling the future, in analytics, we'll call it prescriptive, or we'll call it predictive analytics. We want to tell what will happen in the future, and then that's where our models come in. Our logistic, our random vectors, our regression, and all those things. That's where all these models come in, and then they are rooted in scientific Python. There are some core concepts we have to understand. I believe most of us know this already. Population, sample. Please, I hope we are all cool with these definitions already. I hope we are all cool. Please, if you don't know, tell me, so that I'll hit on it again. Beautiful. I hope you all know. So, there are four concepts I want us to understand in terms of inference. There is sample and population. Population is everybody, so the entire people. And then when you take a subset of people, that's sample. Now, most of the times, you can't gather data about everybody. So you take a sample, collect the data, and then what you study from them, you use to infer for the population. That's why most of the times, Ghana does surveys to help us understand how overall the whole population is looking like. And then these samples, when you collect them over time, when you collect many of them, you can view a map of it, how they are distributed. That's what we call the sampling distributions. And that's the second part. Now the next part are confidence intervals. I want to tell people that after observing this sample, we want to see that for the population, the thing we want to study, the real thing which we can't study because we are not many, which we call the population parameter, is like this, but we use the sample to predict it. And you know, in statistics we lie, but we can't lie with fame. So we lie with percentages. So we tell people we are 95% confident that this thing will lie between this and this. So that when it doesn't work like that, you tell the people, me, I said 95, but I think I should, right? I said 95%. Now, it's the same thing. This is where the confidence interval comes in. You want to tell your manager that he should do this, but you tell the person that there's a 95% confidence that when you take this decision, this is the outcome. And that's what the confidence intervals help you to do. And then the final part, or our final concept, hypothesis testing. This thing is very simple, but sometimes it hits us a lot. The base of this is claims. So somebody steps in this room and says that all the tech people in Ghana, they make $5,000 and above. It's a claim, but you have to test it. How do you see whether what the person is saying is true or not? And there are a series of steps we follow to conclude on this, and that's where the hypothesis testing comes in. Now, we take a first example and look at this. So it's A/B testing. And those of us here who are designers or the UI guys know this a lot. So some of us, you have done 2 designs, right? It's the same app, you have done 2 designs. You want to know which one is good. So that's where A/B testing comes in. You take 2 different people, give them the 2 different samples, right? Let them comment, let them interview them on them. How did they feel the app? How is the UI like? And then you conclude based on their results and see that, okay, so most people like this app or this UI app done because the buttons are like this, they connect it, they say it's more intuitive, it's very interactive, and then they like it. Now, in the same way, that is how we do it in statistics. You collect your data, you load our Python models, what we do. We start with our Pandas, we visualize them, and then we conduct this test to help us know whether, okay, so let's take this decision, let's take this bold step. And that is the roots of everything we do. Now, also, in the same area of confidence intervals, I said already that when we are lying, we don't want to lie absolutely, so we give them percentages. Now, this thing is also help us in model evaluation. So, those of us who have done small data science work, like that, when you're doing your model validation, there are ranges to help us know how our model is performing. We give ranges to help us communicate the uncertainty that you are making chance or you are making space for times that you go and then you see something which can occur by chance, and then that is where this thing comes in. Now, this is a new concept I want us to hit on today, which is on bootstrapping. So bootstrapping is quite gaining noise nowadays, right? It has been there for some time now. So for bootstrapping, we are saying that we have a distribution, you have collected data, and then the distribution here is not normal. You don't know how it's even looking like. The sample is small, but you want to get insights on this. Bootstrapping will say that sample the population. So if you have collected data from people, that same population, sample it different times. So if you generate normal samples, generate many of them. When you generate many of them, that's where it comes to the second step. You calculate a metric. So you calculate something you are interested in. Is it their income you want to study? Is it their gender? That metric or that variable you want to study, that's what you calculate. You build a distribution from the samples you have resampled from the people you have collected, and then you quantify your uncertainty. And this is mostly used in data science to help us gain more statistical stability for the things we calculate before you even conclude or make your insights. Now, for someone who is new in data science stuff, I would want to make this easy for you to understand. In hypothesis testing, we do three things. It's either one, you are comparing something. So you want to compare the male and females in this room, who is getting more money, or I don't like talking about money, but I'm paying money too much. So if you want to compare the male and female here in terms of something, so when you are comparing two different things, this is where the comparison tests come. The t-test, the ANOVA, so they will see and break them all of them. And then when it comes to categorical, so categorical are like groups and genders, those where the qualitative stuff. You want to find out that for this category of people, is this thing having a relationship with this? So it's either you compare, that's the first one. Checking for relationship, that's where the chi-square test comes in. And then in case that relationship is not groups, categories, it's other numbers. So categorical variables like this is quantity, like weight. Let's say weight and height. Want to check whether there's a relationship between weight and height. In this, that's where the correlation test comes in. And then these three things, when you understand them and when you use them, when you have your data, you know what to do. You ask yourself, is it categorical? You go for this. Do we want to compare between two people? You go for this. Are we checking relationship for numbers? That is where the correlation comes in. And then these things help us a lot because when you understand this, you know how to start and then move in with your statistical inference. So I've mentioned the theory already. This part shows us the Python we do. So now we are coming to the coding part. So the models we use, the packages we use, sorry. So Pandas, and then for hypothesis testing, you have seen the models over there. When we are doing our resampling, that's the bootstrapping I mentioned, you see your NumPy there. And then the lying part or the confidence intervals, our Statsmodels help us with that. Now we'll take a simple case and then we'll go to our coding part. So there's an issue, there's a problem with the firm, there's a problem with the business. They've collected data from weekly sales, so this week, next week, they've calculated all. And then they have two branches, so see they have a branch in Ho, another branch in Accra. You want to see whether the branch in Ho, is it performing better than the branch in Accra? So, because most of these companies work in different locations, they are multinational. We want to know where to allocate resources, where to do better, should we give them more attention and all those things. That is what helps them. Now, in our analysis, we have workflows. So workflows are like series of steps which guide you on what to do. So we have machine learning workflows which help you. So for a machine learning pipeline, you start with collecting data, you do this and this and this. It's similar in your data work. That's what we also do. So for analytics workflow, the company already has the data. So we have to create the data. So that's where the Pandas library comes in. We have to visualize to help us see overview and then the key things. That's where we visualize data. We can use matplots in combination with Seaborn, and then we can use our statistical test to evaluate these things to check whether the B is performing significantly. In this case, it is a comparison. So what do you think we use? Our t-test. You get it? From what I said previously. Our t-test. And then the most important of everything you do is that when you are done, you should be able to communicate your insight to stakeholders. So when you are done, we do the interpretation and analysis where we tell people that, okay, so based on this and this is what we do. Now, in analysis, there are some mistakes people do. Sometimes people don't read some values well. So p-values are like, in making our decision, hypothesis testing, our values we compute. We compare with the threshold, which we call the significance level. When the p-value is less, we say that, oh, it is statistically significant. The thing happened by chance. Or if not, we say, oh, it's not statistically significant. Sometimes people don't read these values well, and then they do wrong analysis, and then it means wrong decisions. Also, the second issue is assumptions. So, before you use any model, before you use any test, statistics, they are assumptions. So, you can't use any test at all. I mentioned earlier about the comparison, which one to use. Sometimes people don't check the assumptions needed for the test, and then they just go to use it. No, you have to check before you use that test. And then correlation and causation. The fact that when heights are increasing, weights are increasing, doesn't mean that height is causing weight to increase. This is one thing people mislead. So, as you are growing, your height is increasing. You think your weight will automatically increase. No, the fact that some people are showing a good relationship doesn't mean one is causing one. And this is one of the major problems people do. Now, one thing I want to emphasize is that our ability to translate these business questions into the analysis part and then visualize your uncertainty is what helps you make the impact. It's what makes you better decisions. The foundation of data science is statistics, and then starting well means that you are getting your inferential statistics right before you even start with your machine learning and workflows. Leverage Python, the libraries they are there. You can check their documentation, read about them, and then know how to make better decisions with them. And then interpret, don't just use the test. After the analysis, tell business owners that, so based on this, we are 95% confident you can do this and this. And most of the times, we draft reports, which we pitch to people to let them know that, okay, this and this and this is what is happening. You can continue your journey. I mostly tell people, go to data camp, there are plenty courses there. Take the Python for data science course. Because as Python people, I believe it's very easy and it's very short videos to help you begin your journey in data and then kickstart very well. And thank you very much.